This is an Alinco DR-610 UHF VHF dual band radio that I found at a Hamfest. Don't know anything about it. It doesn't look in the real good shape, but it's not too bad. I'm not a real fan of Alinco. I once owned a DJ580T and that thing was nothing but trouble. I don't know much about this unit other than on the bottom it says NG. I don't know if that stands for nice gear. No, I think it stands for something else. So anyway, maybe it can be fixed. I don't know. It looks like it's been in a mobile for a long time. It's pretty dirty, and looks like the control head was mounted up in the cab, away from the guts of it there. Anyway, I'm gonna hook this thing up and see if we have any life to it, and see if we can figure out what's wrong. I was lucky. I found a service manual on the internet, so maybe we'll get lucky. I don't know. Maybe luckier than I was with that DJ580T. I never did get that thing working. Well, the unit is dead. Which I suspected. It's getting 13.75 volts, so that's not the problem. No, as the coroner of Oz said, it is surely dead. So I guess you need to open it up. And disconnect the power when I do that. Oh boy, this isn't a good sign. This screw is partially out, and it's someone used the wrong size screwdriver, so someone's been in here. Not a good sign. But I'm going to open the lid and see what we find next. Here's the inside of the unit here. UHF power modules here. Here's where the power comes in. This is kind of interesting here, although it's not the problem. The red lead coming in here, I don't know if you can see it on the I can see it through my magnifier. Anyway, there's some bare coppers sticking against from the positive lead to the negative lead right in here. You can see it. So I don't know how that got like that. I don't think at the factory. It's not touching, and that's not the problem, but that can't be good. So we got voltage up to here. What if the problem's in this cable? Okay, here's the cable that connects the remote head to the unit. So I need to make sure that I have control from the power button to the unit here. Yeah, I'll need to check that out next. Okay, power comes onto this main board, and then it goes out to the control head through this cable. See if we're getting B plus to this cable. That would be this connector. I can read it, N682, and the B plus is on the, looks like the fourth terminal. So I have the power on here. Let's see if we got, there we go, we got power, 13.75 volts. So we got power up to the control head, and let's see, I want to make sure the ground is intact. Next, in this cable from the main unit to the head, the B plus comes in this cable on the fourth pin up here. It's orange, so that's where we get our B plus into here. So we got B plus to here, and we know the ground's good because we're connected here. So I guess the next step is to find out why we aren't toggling the power on here. Here's the back of the control head, and I noticed JP501. Here's a red and a blue wire that have been cut. So I don't know why that's done. There must be a reason. I know someone has been into this thing, I can tell by the screw heads. So I'll have to look into that, but that was a little discrepancy. Here's the power switch here, and what I need to do now is find out if that's switching back to the main unit here. This is C507. It's an electrolytic capacitor, 10 microfarads at 16 volts. This is bad. I'm going to replace it with this one here. Here it is on the diagram board, C507, and here it is on the schematic. Right here, C507 is feeding IC503, and IC503 is here, and on the board pictorial it's here. So I'm going to replace C507 and see what happens. Probably nothing, but it's bad, so we got to replace it anyway. So that's next. Okay, the power plug pulls out of this notch. The cover for the amplifier, the UH amplifier, will have to be unsoldered. I have to unsolder the leads, and there's two screws in the back here. Have to unsolder these two leads that go to the output connector, and let's see what else to remove the board. I believe I have to pull the solder from this pin here, and I don't know if there's another one that goes through the board here. Oh, and I've got a screw here and the periphery around the boards. So that's next. Unfortunately, those voltage regulators are on the bottom of this board, the UHF subboard. Okay, you've got a ground shield from the coax and the center conductor that have to be unsoldered, and then you can pull this connector out. There's two screws holding that in. And then you've got a through connection here, here, and here that have to be unsoldered. Be very careful. It's real easy to damage this thing. This is not a fun. This isn't a fun one to work on. Anyway, I'm going to try to remove the UHF board here so I can get access to the other side now. Okay, I have all the screws removed. Two power devices you've got screwed down. This one is connected to ground. This one is insulated. I removed the coax, and now the UHF board can come out. Here's these through connectors that went down to the VHF side. And also there's a connector that connects from the VHF section on the bottom to the UHF board. And now I believe this is where I need to check. Wow. There's no heatsink compound on here. I'm surprised at that. Here's the UHF power module here. This hybrid power module, and it seats against the casting here, but there's no heatsink compound. Well, if I get this thing fixed, there will be when I get done. Anyway, I'm going to do an inspection of this. I'm going to see why I'm not getting any voltage coming through there. IC308. Sure looks like an 8 to me. 7805. Sounds like a 5-volt regulator to me. I've looked on this part list up and down and sideways, and I can't find an IC308. So that is got me scratching my head. Here's IC306 on the UHF board. And here's IC306 physically on the UHF board. But IC308 is hiding someplace. Well, the search goes on. Boy, there's a lot of solder joints on here that don't look very good. I don't know if that's the problem. Anyway, if I understand this correctly, when you push the power button, evidently these transistors here power up these regulators that feed the board. I have yet to find out where this one is in these transistors. I'm not sure where the problem is, but unfortunately these are on the bottom of the UHF board, and trying to power the thing up with that board in the unit with all the connections that go down through this flex circuit board, and then they work their way out to the front panel so that when you push this power button here, it brings the unit to life. I don't know how I'm going to do this. Boy, this thing is really not made to be easily fixed, I can tell you that. And my suggestion is, if you get one of these and it doesn't work, save yourself the frustration. Anyway, I'm going to plug along with this thing and see if I can figure it out, but I think right now I'm going to look for some bad solder joints and try to find that IC308 wherever it's hiding, and try to figure out a way to power this thing up. But it's completely dead, which normally is a fairly easy fix, but not in this case. This capacitor C472, when I try to measure the ESR, I get open circuit touching the solder pads, but I got a legitimate reading touching the actual pins. So it looks like I've got bad solder joint, one of these. They don't look that good. I'm going to touch them up and see what happens. The ESR meter showed this is an open circuit across this capacitor. C14 is bad. Its ESR is it should be 0.6, and it's higher than that. It's like 4 point something. And here's the bad one here, and the one I'm going to replace it with here, I'm going to replace it with a I can read the darn thing. After staring at this all day, 220 at 16. So it's a little higher voltage. It's actually, yeah, it's about the same size. A little higher voltage. And of course that goes here. Part of the pad came up when I pulled it out here, positive side, but hopefully that won't be a problem because it looks like it makes its connection on the bottom. You can see here where it runs on this line over in this direction here. So that shouldn't be a problem. It looks like it pulled the via out when it came out. Not good, but that's what happens. I've got some 10 microfarad at 16 caps here with high ESR. They're surface mount. This one, this one, this one. This one's actually open. And this one. I should probably replace all of them because the other one is probably going to follow. So anyway, bad capacitors. I got 3 crystals here and I gotta try to sandwich these in here. This one won't be too bad over here, but these are going to be not so fun. Replacing these surface mount caps are not my idea of the funnest aspect of this hobby. And if you look on the board here, these things are pretty small. To give you an idea, here's a finger. Here's another shot. These things are pretty teeny. And there's a number of ways of removing these. One way is to use a hot tweezers. This is a Heiko 936. It's a hot tweezer which you can use for some components. Unsolder them. And that works for some. It might work for this one. Barely. But some of these it's not going to work for. Like in here between these 3 crystals. There's no way you're going to get this in there. And for that, instead of the hot tweezers, I prefer to go with 2 soldering irons, needlepoint soldering irons, or small tip soldering irons. You can get in at an angle, and if you've got really close parts like in here, this is a pretty narrow tip, and I can get this in between this crystal and the pad here. And that works for both this style, the little cans, and the other packages here. Still can't believe they didn't put any heatsink compound on this hybrid amplifier here. The through-hole components aren't that difficult. These I replaced. Didn't really have any trouble with those, but now, of course, what you have to do before you can replace them, you have to remove them. The only way to remove these caps without destroying and making a mess is a method I don't really like. And some people advocate it, but I don't. But I use it sometimes, like here. What you do is you get a hold of the cap with a needle nose or pliers of some type, and then you slowly work it back and forth. What you do is you want to break off the leads from the cap without disturbing the pads on the circuit board. And when you do that and lift it off, you'll leave the connections to the cap will almost always be left on the board. And then what you have to do is you have to clean the pads, use flux, and then and go from there. So I'm going to do that step next. I've already removed the bad capacitors in 3 locations, and now I have to clean the pads off. I actually I got the remnants of the leads on the caps off, but I need to take the old solder off. So first thing I'm going to do, add a little flux to the pads, and then I use solder wick. I always add a little solder flux to the actual wick. See, I got about 380, I think. 380C I got for temperature. Might be a little high. Some of the pads, especially the ones that are on a ground plane, are a little tougher to desolder. You add a little fresh solder to the tip, that helps too. Not a lot of space to work between some of these. Yeah, that looks clean. These little vices are nice. Clean the pads. Now these boards are marked with a positive point here, and if you look at the, if I can hang on to it here, the black band here is the negative, and also if you look on these small little cans, which I can't hold it and show you here, but if you look on the positive end, there's a little chamfer on the positive end, so that will face me this way. And I think I'll do this one first. See how it's going to fit here. Not much space between the leads here. Boy, there's not much at all. This is the flux I'm going to use. what I normally do, I'll put a little bit on top of this little cup, and then using a screwdriver tip, put a little blob on that. Now comes the fun part. You can see between the leads here, and not much, and you have to span the gap. Okay, one of these leads, I got a little bit of solder. What I want to do is tack this end. I'm going to go back and reflow this end with a little more solder. I just tacked it on there, so. Check for ESR if I can get these probes to cooperate. Okay, that's good. Well, there's the first one in. I have 1, 2, 3, 4. How many more? 5 on this side? Anyway, I won't bore you with that, but I will get at it. So stand by. Well, I gave up on this one. I had to cheat and use a regular cap. I could not get this in there with that crystal there and this multi-layer board. I didn't want to pull the crystal out. I could not get in there to solder that. So this one's replaced, this one's replaced, this one's replaced, this one's replaced, this one's replaced. These two are replaced. Yeah. I'm not sure if I see one of these at a Hamfest. I'm going to buy another one that doesn't work. This has been a real pain. But anyway, we'll see if it works. Keep my fingers crossed. I found another bad transistor here. Q337, it's a PNP. And that's this one right here. And this is the base, collector, and emitter. So it's a PNP. So we'll put the negative, I don't know if you can see, I can't see the meter here. Negative on the base. Here's the base to collector. Short in both directions. Here's the base to emitter. Open in that direction. There must have been a cap. They gave me a little bump. Yeah, it's open. So this transistor has to come out. I'll have to use hot air on that. Boy, this thing is turning into a nightmare. Here's where the power comes in on the DC in jack. 13.8 volts comes in here, and then this transistor Q337, when it's activated, applies the power through this regulator here, and that's driven up, goes up to the processor. But anyway, Q337 has got a base collector short. I believe it's a base collector short. I'll check in a minute. This transistor checks okay. This is a small signal transistor. This is a bigger transistor. This little fly speck here is Q337, a PNP transistor. This is the one that supplies power to that first regulator coming in here. It's a PNP, and left to right is base collector emitter. So since it's a PNP, we'll put negative lead on the base. Okay, that's a short. And going the other way, this leads a collector where the negative lead is on the other side. And there's a short. So base to collector is shorted. Don't sneeze or you'll lose this thing. That shows open circuit. Base to emitter. We should get an emitter drop. No, that's open. So we've got a base to collector short and a base to emitter open. So that transistor's bad. The other transistor is Q338. It's an NPN. That transistor is even a smaller fly speck. This is a 2SC4081, and it's an NPN. Base to emitter. Okay, that shows a diode drop. And in the other direction, base to emitter. That's open, and that's fine. Base to collector, which would be here to here, we get a diode drop, and the opposite polarity, it's open. So this transistor is good. So once again, this transistor is bad, this transistor is good. So I need to find a PNP equivalent of a 2SB1302. And hopefully that will be the reason we're not getting any power. Well, I hate to give up, but I've reached a snag, and it's this little PNP transistor. Problem is, I don't have any vanilla transistors that will fit on this board. They're really small, and there's no room in this board. When you mount this in here, there's no room. Plus you got to make the connections between the VHF board on the bottom and this connector. This is a VHF board, and the amplifier, the PA. So what I think I'm going to do, I'm going to order some of these transistors. There's still a lot wrong with this. It's pretty obvious I wasn't the first one to get into this thing by missing screws and some pretty bad soldering. And not that my soldering was much better. Boy, I had a hell of a time with this one right here. And I had a compromise with a regular electrolytic. The rest of them went in. And when I do this, I always check them once I insert them in the circuit. It's so easy to short those pads out. They're so close together. But anyway, I'm going to close this one out for now. If I get some of these transistors and I can get this thing back together, I'm going to try to get it working, but I'm going to make it in a separate video. If you don't see part 2 of this video, it will mean I wasn't able to fix it, which is very possible. These are really hard to work on. Some of these parts, I can't even see them. You need a microscope. Anyway, sorry we weren't able to get it fixed. I was anxious to get it fixed and put it on the air and maybe make some contacts locally here, but maybe that'll be for the future. So anyway, thanks for riding along, and we'll see you in the next one. Thanks for watching. Bye for now.